One last verification lesson, I promise, at least in the chapter on matrices. So take a deep breath and let's go. As usual, taking the left hand side gives us the inverse of AB. Brackets need to be considered first, which contain a simple multiplication of two matrices A and B. Before multiplying them, we will take their determinants to check if these matrices are non-singular. If they are not, we will stop solving the question right here. We do this because we have to calculate the inverses of A and B later on in the right hand side, and an inverse only exists if the determinant is non-zero. So, the determinant of A will be 3 into 0 minus -1 times 1, which is not 0. Similarly, cross multiply the numbers of matrix B, solve them, and again the result is non-zero. Thus, we can continue. We are now finding AB. Place A and B next to each other. We have to fill 4 positions. This is the 1, 1 position. This is the 1, 2 position, the 2, 1 position, and the 2, 2 position. Following what we have already learned, take the first row of A and multiply it by the first column of B. So it will come here at the 1, 1 position. Then the first row with the second column will come here in the 1, 2 position, and so on. Adding up the values and we arrive at AB. Now we have to find its inverse. For that, we need the determinant and adjoint of AB. To find the determinant of AB, cross multiply these two minus these two, and we get 3, which tells us that the matrix AB is also non-singular and the inverse can be found. For the adjoint of AB, interchanging the diagonal entries and changing the signs of other entries gives us the adjoint. Let's put these values in the formula for the inverse that we have seen before. Here, every element in the adjoint gets divided by this 3 down here. So, this is the inverse of AB. We have successfully solved the left hand side. Now I'll take the right side of the screen to find the right hand side. While this may seem a bit lengthy, but it's quite easy. We need to find the inverse of B multiplied by the inverse of A. We have already calculated the determinants of both, so we are directly finding the adjoints. Take B first. Swipe these two, change the sign of these, and put it in the formula. But we won't solve it further right now. Next, we need the adjoint of A. Swipe and then change the signs. This is the inverse of B, and this is the inverse of A. We only need to multiply them now. We can ignore this 1 upon 1, but in case if it were anything else, we would take the fractions together at the left side like this and multiply them. For the final step, multiply the matrices, taking the first row, first column and multiplying 2 with 0 and 1 with 1. Next, do the first row, second column by multiplying 2 with -1 and 1 with 3. Similarly, do the second row, first column and then the second row, second column. By solving the rest and finally taking this 1 upon 3 inside, you can see that this inverse of B into the inverse of A is clearly equal to the inverse of A by B. Thus, the left hand side is equal to the right hand side and the relation is verified. Well, we have covered the basic and advanced operations as well as the verifications of matrices so far. You are now ready to start applying them. Different sorts of questions are waiting for you in the next lesson. Go ahead.